I want to do is put down the standard, and this is something I need to do as a teacher, so we'll all get used to it so we can learn the standard. So algebra, right? Algebra, polynomials, rational. It's 2 and 2.3, so let's write what that is, okay? So it is on 2 and 3, and it has to know and apply the remainder theorem. So apply, no, you can't see it. No, we're going to put remainder theorem. Theorem. And zeros of a polynomial. Okay, please write that down, okay? No, remainder theorem and zeros of a polynomial, okay? Alright, so first of all, if it says p of x, this is a polynomial. Polynomials, first of all, are curvy. Every time you add an exponent, it gets curvier. Does that make sense? So you think about an x squared as a nice parabola. An x cubed is going to have one more bump. And with polynomials, they just get super curvy, all right? Varying heights and degrees. They just kind of go like a whole bunch of curves, all right? Now, p of -3, that's an x value. So if I plug in p of -3, I would get its corresponding y value. So I know for sure what I'm finding is -3 something, okay? -3 something. So let's plug it in, and I'm going to use my calculator, and this time, Colby, hopefully I'm going to do it right. Yeah, I get all the exponents in the right place. So p of -3 would equal, well, 2 times -3 to the 5th power plus 5 times -3 to the 4th power minus 8 times -3 to the 3rd power minus 14 times -3 squared plus, I'm running out of room, but I'll squeeze in 6 times -3 plus 9, okay? And honestly, I'm sure I could probably do it by hand, but, you know, I'm probably not going to make a mistake, provided I put it in right. Probably going to get it right if I put it in right using the calculator. Okay, so 2, I'm going to go -3 to the 5th power, and if I do make a mistake, please tell me, plus 5, -3 to the 4th power, subtract 8, times -3 to the 3rd power, subtract 14 times -3 squared, plus 6 times -3 plus 9. Okay, so I put the whole thing in the calculator. Let the calculator do the work. For crying out loud, let me show you what I've got so you can see it. Okay, I've got it all in the calculator, right? Enter. I get answer of 0, okay? So what I know is that p of -3 is equal to 0, okay? So that tells me a couple of things, okay? So if it's at 0, then I know if this is a point, think about it graphing-wise. I don't know exactly what it looks like, but if I take a look at a graph, I know at 1, 2, 3, at -3, it's got to go through the x-axis, right? I don't know what it looks like, but I know this much of the graph. If I plug in -3, I get an answer of 0, okay? So that means it's an x-intercept. We're also going to call that a root. So if it is a value that gives you an answer of 0, it's a root, okay? Any value plugged in that gives you an answer of 0 is called a root, okay? Now, if that's the case, it's also going to be a factor, okay? So x minus 3, is that a factor? Yes, this is going to be a factor. Is it a root? Yes, and x plus 3 is a factor. Okay, what does a factor mean? Let's go back to basic math. Let's go back to plain old basic math. So, is 4 a factor of 20? Is 4 a factor of 20?
Yeah.
How come? You're right, how come? Why is 4 a factor of 20?
4 times 5.
Goes in evenly, right? Is there a remainder?
No.
No. Is 2 a factor of 10?
Yes.
Because it goes in evenly, there's no remainder, right? Is 3 a factor of 10?
No.
No, because you'd have a remainder. It doesn't go in evenly. So I'm telling you that x plus 3 would go in evenly into this polynomial. So that means that when I divide it, I should have a remainder of 0, okay? So let's do it using synthetic division. Now, how do you do synthetic division? Well, let's see. tried to go through this in the notes on Friday, but we'll start again. So first of all, when you do synthetic division, we're going to take the coefficients of my polynomial. I do an upside down. This is the way I do it. I do an upside down division. Do an upside down division. Just do that. So when you do synthetic division, you'll know it's going to be synthetic division because you go upside down. You guys did this last year, didn't you?
Yeah.
Okay, good. That's the nice thing. So you've seen this before, okay? We're going to take it quite a bit further. We're not only going to divide it, we're going to look at why it works, what it's all about. What does this all mean, right? So I'm going to go and put my 2 here, okay? 2, 5, -8, -14, 6, and 9. Now, if there is a missing term, I'm going to say this 3 times, meaning this is exactly 5, 4, 3, 2, 1, right? If there's a missing term, like maybe there's no x squared, put a 0. Fill every single spot. Does that make sense? I'll show you this, okay? Every single thing must, here's a 5, 4, 3, a 2, a 1, and 0. If you're missing a term, put a 0 in as a placeholder, okay? Now, when you divide, normally you subtract, right? You write division, you like bring it down, you subtract. You guys agree? But if we take x plus 3 and make it x equals -3, we've already taken the opposite of it, right? So we do synthetic division. If we use the opposite, the -3 out in front of here, we've already done the subtraction. So we do synthetic division. We'll add because we've already done the negative. So really, in a sense, adding the negative, which is like subtracting. You want me to say that again? We've just made this its negative. So when I multiply through, I will add because I've already added its negative, which is basically subtraction, isn't it? Okay, so now here's the next thing I want you to do. Okay, we got the -3 out front, so you take the opposite of that. Put a line right there. Okay, put a line right there. Okay. Right below the 9, which is the 0 term, I'm put a little box because that's where my remainder goes. That's my remainder, which will be 0. How do I know that already? The remainder will be 0. Because in fact, it's a factor, right? It is a factor, so this had better be 0. If it's not 0, then I made a mistake. And that never happens, does it?
Except for on Thursday.
Yeah, never. I never make a mistake. All right, so here's how it works. Yeah, Quinn?
You said that you made a mistake on the film, but you caught it?
Yeah.
You never caught it on Thursday.
That's what Colby said. Yeah, I guess I made another mistake. Yeah, I'm on film. I'm admitting I'm making mistakes. Okay, anyway, let's keep on moving, huh? So what do you do? Step 1. So here's the key. Everybody watching? Step 1. Slide the first term down. Okay, slide the first term down. Just bring down the 2, put it there, okay? Slide it down. That's the first term. You got to just bring it down, okay? And now, what am I going to do? I am going to multiply. Okay, I'm going to multiply. -2. 2 times -3 is a -6, right? And then I'm going to add. In division, normally we would subtract, right? You guys remember doing division? You'd subtract, but we don't subtract because we've already made it a negative. So we add, we get a -1. We multiply, right? -1 times -3 is a +3, and then we add, right? -8 plus 3 is a -5, right? And then we multiply. -5 times -3 is a +15. Am I going too fast? Okay. -15. -14 plus 15 is a +1, right? And we multiply. 1 times -3 is -3. Again, we add. 6 and a -3 makes a 3. We multiply. Now we get 0. Good. Now, the whole idea is that really originally we were dividing polynomials with x's, right? And we did divide in a sense by an x plus 3, even though we didn't show the x. Okay, paying attention? So what happens if you divide this by an x term? My answer should be an x to the 4th. Okay, think about it. I really divided, even though I didn't show the x's, I really divided by x plus 3. So if I divide this by an x, it reduces it to an x to the 4th. So my answer is going to be 1 degree less. My answer is going to be 1 degree less. So here's my answer. My answer is a 2x to the fourth. Because really the whole problem had to do with x's, not with numbers. Minus a 1x cubed minus a 5x squared plus a 1x plus 3 and remainder 0. Now, if I were to take, are you listening? If I were to take and multiply this answer, my answer, if I were to multiply this answer times my divisor, if I take this and multiply by this, if I take this and multiply by this, what's the answer?
The top one.
Yes! It's got to be this. Has to be, right?
Yeah.
Nice job. Okay? And it is a factor because it got a remainder of 0, okay? Are you ready to turn the page?
Yeah.
All right. All right, example 2. Okay, graph without a calculator. All right, so now this has to do with zeros, okay? I can do this. I mean, I can put it in my calculator. I can take a look at it, but I want to do it without it because actually it's pretty easy. You can do this pretty quickly. So I'm going to go ahead and put my x-axis, my y-axis. We do not care about the height. I just want the shape, okay? X-axis, y-axis, okay? First of all, this polynomial has zeros. At x equals 1, has zeros at x equals 1. Because if I put 1 right in here,
We can't see.
if I put a 1 right in here, I get a 0, don't I? Oh, that's supposed to be a 2, darn it. That's supposed to be a 2x. My bad. Got to fix that. It's supposed to be a 2x minus 3. Where's a mistake already? So another 0 is if 2x minus 3 equals 0, I'd have x equals 3 halves, or 1.5. Okay, that's supposed to be a 2. My bad. I was in a hurry. I'd have another 0 at x equals negative 1. But I'm going to have that twice. And that is a double root. Because it happens twice. Even though it's the same number, it happens twice. That's a double root. And I'm also going to have a 0 at x equals negative 3, okay? Because if x plus 3 equals 0. I mean, the way you can do these, if you're a little confused, is put x plus 3, set it equal to 0, and solve. Take your x plus 1, set it equal to 0, and solve. Take your 2x minus 3, set it equal to 0, and solve. And take your x plus minus 1, set it equal to 0. Now, these are zeros, so it's where they cross the x-axis, right? So let's do that. I'm going to have at negative 1, negative 2, negative 3, 1, 2, 3, right? I will have a 0 at 1, so put a 0 right there. There's one of my zeros. X-intercepts, or roots. We're going to call them all the same thing. 3 words. We'll call it an x-intercept, we'll call it a 0, and we'll call it a root, okay? We're also going to have one at negative 3, right? We're going to have one at 1.5, right there, okay? And we're going to have a double root at negative 1. So this, we're going to write this one twice. How do you write it twice? You can't, but that's a double. And I'm going to put, that's a double, okay? How am I doing? All right. Now we talked a little bit about end behavior last week. I wasn't here, but we did talk about end behavior, okay? If I were to multiply this whole thing out, now here, think about it, okay? That's an x, that's a 2x, that's an x, that's an x. I would have a positive x2, let's see, it'd have a x, 1, 2, 3, 4, 5. I really have like a 2x to the 5th. If I multiply this all out, I'd have a 2x to the 5th. I would, 2x to the 5th, blah, 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 okay? Does that make sense? But since what I have is, in this term, I have it in factored form, okay? So, because this is a positive term, end behavior is going to go off to infinity. So at this very last root right here, my graph is going to go off to infinity, okay? Right? My very last root, at my last 0, it's going to head off to infinity. Does that make sense? If this were a negative term, it'd go down, okay? Now, what happens? It's a polynomial. They're curvy. They're going to go in and out of the zeros. That makes sense? We're going to go zip, 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 zip. We're going to go in and out of our zeros, right? We don't care about the height. I know this. Check it out. So my graph's going to go down, but it's got to come back up to go through this one, right? Think about it. It's going to go down. It's going to come back up because it has to go through that one, right? It's going to go up a ways, but it's got to come back down because it's got to go through this one. How many does that make sense? Now when it comes to the -1, it's a double root. Everybody watch. Everybody? It's going to go, everybody watching? Everybody watch? It's going to go through -1 and back through it again. It's going to go through -1 and through it again. Touch and go. A double root is a touch and go. It's going to go through watch, it goes through -1 and back through again. So then it goes through it and back up. And then it's got to go through -3, okay? That is the shape of this polynomial. In fact, if I wanted to say, well, gosh, check it out. If I wanted to graph it anyway, we could. If I go parentheses x, I know I'm right, but I'm going to prove to you I'm right. I've got a 2x minus 3. I've got a x plus 1 squared. And I've got a x plus 3. Let me get a good window on here. A window. Let's go from -4 to 4. I don't know, maybe -20 to 20. I don't know how big it is. And let's graph it. Oh, look at, there's that touch and go. Look at that. That's kind of what I graphed, isn't it? Man, I'm so smart. I don't need a calculator. Okay.